Hi everyone, it's John from Chicagoland Fire Photos, and I'm bringing you guys a brand new series that I'm trying to work on my YouTube channel. I'm trying to branch out, do some more informational content because I like talking, I like explaining things, and I like teaching. So this is going to be a new series called All About the CFD, and in a ton of episodes we're going to cover just a huge range of topics explaining pretty much anything and everything there is to know about the Chicago Fire Department. The first episode, where I'd like to starts off with the most basic piece of apparatus the city runs. Responds to almost every call. If you call, you'll probably get an engine. The engines in the city are pretty much the backbone of the department. They do a ton of work, and they're not going anywhere anytime soon. So in today's video, we're going to be explaining the basics of the CFD Engine Company. So, getting into the brass tacks, the basics of the Chicago engine. Staffing is 5 throughout the entire city. It's staffed by an engineer, which is a promoted position. They stay with the rig at all times, and their only job is pump ops. They don't go into fires. An officer, so they'll have 2 lieutenants, 1 captain, for the 3 shifts, and 3 firefighters, to total 5. The riding positions on an engine for firefighters are: you have the pipe, which is a guy in the nozzle, the heel, which is the backup guy, he's second up, helping the line get up there, and then you have the hydrant. The hydrant guy's going to make a hydrant, and then he's going to go get dressed and assist the engine with interior operations. The city runs 98 engines out of 96 firehouses. There's 2 firehouses that are doubled up. Engines in the city respond to pretty much everything: EMS, civilian assists, wellness checks, COs, gas leaks, any type of fire that could happen, accidents, hazmat, anything special ops. You'll get at least 1 engine. Pretty much there really aren't that many calls in the city where you're going to get anything but this. Moving into the actual apparatus itself, this example here, we have engine 44. This is a 2004 Spartan Gladiator, FDD 620 on the numbering. This has a 1,500 gallon per minute pump and a 500 gallon tank. That is the standard for engines in Chicago. Some of them have foam tanks. The new engines that are being bought have 30 gallon foam tanks. A couple of these Spartans have 30 gallon foam tanks, and a select few Spartan engines throughout the city are what's designated as high pressure companies. So they are a 2,000 gallon per minute pumper, still with a 500 gallon tank, and they can be special requested if high pressure pumping is needed. If not, they just act as a normal engine company. The only different thing they carry is they have 3-inch high pressure hose in addition to all the other hose loads that are carried on this truck, which we'll get into in a minute when I'm done explaining this. Finally, the basic role of the engine on the fire ground. Engines in the city, they're not going to be doing truck work. You're not going to see them doing anything but putting out fire. The sole responsibility of the engine company is to establish a water supply and put the fire out. That's it. That's all they do. And that can be through using their deck gun, using the ground monitors that they have, or hand mines. One of the things that you'll see when we get into the hose loads is redundancy. Like I said, there's 98 engines. Everything on these rigs, the reason they're set up so simply, the reason why they don't carry a ton of equipment, is because you need to be able to take a firefighter from, let's say, the 24th Battalion on the far southeast side, doesn't run a lot of fires. They've got pretty much all 1-story brick or frame houses, and you have to be able to take him and put him at, let's say, the 9th Battalion in Uptown, where they have all manners of building construction, from 2 flats, single-story residential, big multi-family 3- and 4-story apartment buildings all the way up to 20, 30, 40-story high-rises. So redundancy is a very important thing in the department because everybody needs to be able to do everything. And that's about it for kind of the general overview of these pumpers and how the engine works. And now we're going to get into my favorite part of this, which is the hose loads. Okay, so starting off with the hose loads, we have the Backstep. Now, to preface real quick before I get into this, this segment of the video I originally thought I recorded. My camera had a problem where it stopped recording right when I started it. And so I talked the whole time, thought I had the recording, and I began to edit this video and I realized that I did not have it. So I'm going to have to make do with this. So getting into these hose loads, how I talked about redundancy. The redundancy of the back is at 7, 7, and 7 everywhere. This load of 2.5 is 700 feet. This load of 4-inch LDH is 700 feet. And this load of 2.5 is 700 feet. So getting into what is the engineer's side lead out, this is probably the most common lead out that you'll see stretched in the city. The second most common is probably the Crosslays. This is 700 feet of 2.5 flat loaded and then into 2 horseshoes of 2.5. And that goes into a 2.5-inch shutoff pipe, which reduces it down to 1 3/4, and then that goes to this 1 3/4 horseshoe of either 100 feet or 150 feet with any number of the issued fog nozzles in the city, either the Elkhart Brass Chief or the Task Force Tips Metro. It's company dependent on what they run up here, either 100 or 150, sometimes 200, but that's very rare. In the middle here, we have the supply line. So you'll see later on the bumper supply line, this is the extra. So if they go off the back, you have 700 feet, 4-inch supply line right here, just flat loaded, ready to go for the hydrant guy to grab. Now, moving over to the last lead out off the back is the officer's side lead out. This is typically for used when you need a big line for defensive fires. It can be used to feed the blitz fire monitor, and its most common use is for exposure protection on apartment building fires that have wood back porches. It is 700, same as the engineer's side. It is 700 feet of 2.5, which is flat loaded into 2 horseshoes, but instead of going into a shutoff pipe, or sorry, instead of going into a horseshoe of 1 3/4, just stops there. Most houses run it with a smoothbore shutoff pipe, but they also have the option to run it with a 2.5-inch fog nozzle. And before I finish the rest of these, before we move on to all of those, I'd like to preface that these are the base leadouts. This engine company runs them pretty standard. Like this is they don't really have any specialized leadouts on here. That's why this is a great engine to use, because this is the standard CFD leadout. Some firehouses pack differently. Some firehouses buy their own nozzles and put them on there. But what I'm trying to give you is just the base overview. Now we're going to move into the Crosslays. Alrighty, so moving up top here, we have the second main line that's pulled, and that is the Crosslay. So from above, you can see it's either 200 or 250 foot, it's company dependent, 1 3/4 Crosslays that are pre-connected. The typical city guideline is to flat pack. Sometimes you'll see other different hose loads, but this is kind of the norm. We have two examples of nozzles that the city issues. We have the Task Force Tips Metro 1, and we have another Elkhart Brass Chief. These are stretched pretty commonly, but a lot of times companies will still opt for that 700 foot to the horseshoe off the back, just because you never really run out of line with that. But now we're going to move on to the front bumper. Alrighty, so now we're off the front bumper. This is a concept that was originally created by the city of Chicago. It's called the rapid water concept. So basically, hydrants in the city are every 150 feet. So this idea was designed so that basically you could park on a city block, you're 150 feet too high. So, because of that, you have our supply line up here. You have 150 feet not pre-connected, so it's this load right here, and then on top, in case let's say you're right up on a hydrant, you're within 15-20 feet, we have this little extra length here that already has its own storage pre-connected on there, and that is pre-connected off the front, and it's a 20-foot little extra length, like I said, and that'll typically be used, like I said, within 15-20 feet of the hydrant, or sometimes for like transferring water between engines if they're that close. Now we're going to move on to the trash line. Okay, so now we're on to the last line on the rig, and that is the trash line. Now this is something, it's one of the last parts of the engine where companies can really choose what they want to do with this tray that runs along the entirety of the engine. This is pretty much the most basic example. This is 100 feet of 1 3/4, just on an old Akron brass fog, but you'll see all over the city, depending on the neighborhoods, companies do things way differently. So when you get downtown, uptown area, places that have high rises, stuff like that, they will put their high rise packs up here so that they're quicker to access instead of being in the compartment. And they'll I'll throw an example up right here where you can see an example of an engine that has their trash line really tightly packed, and then room that they can still put high-rise packs in. Or it will just be all high-rise packs. Another thing that's been a big source of a big push on the south side of the city that's popped up is making this into a third Crosslay. So what they'll do is they'll pre-connect it off the rear, and instead of this 100 foot for auto fires, stuff like that. That's what this is normally used for. Rubbish fires, auto fires, stuff like that. They'll put 200 or 250 feet on here and really stack it. I'll throw a picture in of kind of what that looks like right here. And they'll really stack this up. And they can lead it out off the back as an extra Crosslay, where if that 700 up top isn't enough, or is if that 700 is too much, and that Crosslay won't really reach because it's in the middle of the rig, and in Chicago the engines pull past the building. It's been a really versatile line that a lot of companies have started using, and that's why I'm kind of a big fan of checking out the trash line at a bunch of different places, because they all do everything differently. Now we're going to move in to the final line, which is the high-rise packs. Alrighty, so we're almost done with the hose lines. This is the last part. These are the high-rise packs. So what it is 4 50-foot lengths of 2.5 in 4 bundles that look kind of like this. Here. So 3 of these bundles don't have a pipe, 1 does. The pipe that's on these is kind of our specialty high-rise pipe. It is a TFT Vortex smooth bore. It's got the ability to do stream and a vortex kind of fog thing, even though it's a smooth bore. So these will be taken up by the engine and let out for a grand total of 200 feet. Now, this back. Now, sometimes that vortex pipe will actually be used by companies up on the Backstep Leadouts if they choose, they like it, and they'll just find another one for this high-rise pipe. The other thing, like I mentioned before, with the 2,000 gallon per minute pumpers that have to carry 300 feet of 3-inch, that is carried here. So this rig is, of course, a 1,500 gallon per minute pumper, so it doesn't have that upgrade. But on those rigs, half of this compartment will be cut off to the back, and it'll be a small hose bed where they can flat load that 300 foot of 3-inch, and then they just sandwich these high-rise leadouts in the high-rise bag in there. So now we're all done with the leadouts.